Is it fine now? This screen is coming. My software screen is coming.
It's right.
Yeah, great,
Yes,
great,
sir.
great,
Yes, sir.
great.
It's
Okay, so this is actually the ENVI software. If you see, if you type ENVI, so this is actually the ENVI 5.5614, which actually I'm using. So in the ENVI, we have this module is called SARscape. Okay, so this is SARscape is a separate tool. You have to install it with this SARscape module. Okay, so here you have see we have a various options. Okay, to directly process this data set. So first is we have to show you that it's a download option. So download option I already showed you from our sites. Okay, so like the hub also you can download, and here also you have a direct options to download. Okay, so if you click over this, okay, so here you have an option to download. So you go to this optional file. So if you have a particular region shape file, so you just upload it here. Okay, and then you go to the parameter. So here you have to, if you don't have the shape files in parameters, you can give a particular coordinate, which place you have to download the date information. Okay, and you can give the date from which date to which date you want to download. Okay, and then you go to the platform. So you can select your Sentinel-1 or Sentinel-2. So this obviously SAR data is for Sentinel-1, so you have to select Sentinel-1. And you can go to this next informations, which is actually required. There's a product types you have. Okay, so you have to select here as a single looks, whatever you, as a tool, SLC datasets you require. So change it as SLC, and acquisition modes you require. So you just select here IW. Okay, and obviously this is all orbit. So ascending or descending, whatever you want. What I found in this place of Sundarban over time of crowding. So what I got I think descending data is giving a better information. I just little forget about that, but still it is I think in descending mode you can take the data. And next is you have to select here. This is already done. And can you please mute because so many noises is coming actually. Yeah. Hello.
yes, sir. Yes, sir. Yes, sir. I'm checking it.
Yeah. Yeah. Okay. So this is a polarization mode. If you already, I told that if you have a different kind of polarizations like VB and V, so you can select. Otherwise, you go for the all. Okay. And within all, you have to give here as a login and password. So if you give your login password, whatever I'm giving there, which I forget actually, so that you give, and after that you go to the output file. So you have a two options. What is progress file or is unzip file? Okay. So unzip file is actually you have to save whatever data set you will download. It will unzip it here. And progress file is just like a supporting file, which is actually helping you to support the data whenever you want to download it again. So you just recall the progress data file and you can directly download. So after you fill all these steps, this execute button will be activated. Okay, you just click the execute button and automatically your data sets will download. Okay, so this is downloading, it will may take time. Okay, because I told you this is almost a 6 GB data sets which you are going to download in a SLC product. Okay, so it will take a huge time and your internet connectivity is required very good. So only one difference I'm just telling you, that is from my side, that is which I feel if you're downloading from here, obviously it is a very good option because you have to recall and everything is fine. But the problem is if your internet connectivity is not good, if you are processing it here, downloading it, giving here, so means suppose in case of internet will gone, so whatever the processing will be stopped. So it will if you are starting again, so it will start again from the past. That is the what I feel is a disadvantage. Maybe in future it will be also recovered. But if you go and download in the Copernicus hub using the Chrome, so Chrome there is one options will be there. So if somehow your internet will gone, it will stop there. You can restart your download. Whatever this downloading done from the next one was you can able to download. That is the advantage. Okay. So anyway, you download here and there, no problem. Now next steps is you have to import your data. So how will you import the data? So first is you have to go to the SARscape and go to this single sensor information. Okay, and here you just see whatever satellite image you have. According to that, you just select it. So here I have Sentinel-1, so I'm just selecting this. So in the Sentinel-1, what I need to select, just see here you have an input file. So just go to the browse. Okay, and you have this. This is the image which are downloaded. Okay, and see this. This is a mainface.save file. So this file you have to select. Okay, just select it, open. So now your file is loaded. You go to the option file. So again, I will suggest not to do subsetting or taking your, means you have your polygon shape file over here. So using that you can subset your area. So if you feel this area is large and you want a small area to process, so because many people they have a problem with their size, means hard disk capability, there is less size. So you want to reduce the size, then you can directly cut it here. But I cut it in last, whatever I feel. Okay, so that is, you go to the parameter tab. Now you have to make your QPL, QL, make power as a QL. Polarization, you will make it all, and mosaic system track is true. And the rename using file is also making up to true. Then you go to the output file options. Okay, so here you have to select, see, either you have an option here to create as a preference. So whatever folder you have to create as a preference, it will go and save it here. Otherwise, you just right click over here, change the output direction. So wherever you want to save, you select that folder and save it. Okay, so once you save, then you just have to click this execute. Okay, so importing is taking some maximum time. It will take almost 30 minutes to import the data, 20 to 30 minutes. Okay, according to your laptop capability. Okay, so that is the, means for my case it is taking almost 20 minutes to import the data. Okay, so after doing this, how the data set is looking, so I'm just showing you. So this is what it will be looking like this. So this is a VV, this is VH, and this is VV. So now you see in the VV and VH also you can see the difference. Okay? In the VV and VH also you can able to see the difference. Even if you focused over the water body, then you will get an idea. Okay? So if you see, this is a image of VH. Okay, and I just opening the VV. So see VV, the water body, underwater also, so few informations you can able to see it here. But in the VH, you are not getting that information.
ವಿನೋದ್
Yeah,
ಇಲ್ಲಿ ಕೊಟ್ಟವ್ ನೋಡು
yeah. So now,
ನೀ ಯಾಕೆ
uh,
ಪ್ರಿಂಟ್ ಇಲ್ಲಿದೆ
okay, sir, can you please mute yourself 1 minute? Yeah, thank you. Okay, so now here, if you see here, so this is the VV and VH which I just imported. The next step, what you have to do, that is the filtering. You have to clear your image or you have to filter your image. So to filtering, doing filtering, you have options here. So you have to go to the basic, you have to go to the intensity, okay, and then you have to go to the filtering. So here you have to go to the single image filtering technique. Okay, so I'm just clicking over this. Okay, and after clicking, you have to give the file we just exported. So once you imported, now you will see this files. Okay, so you will see after imported, you will find this file. This is called PWR file. We call as a power file. Okay, so you take the both power file. You select this both power file, which is actually, if you see, oh, it is gone. Okay, okay, yeah. I'm just canceling this. Okay, so if you see here the extension, okay, if you see this extension, what is this? This is the PWR. So once you imported that file, this PWR file is actually extracted. So that you have to select here on your, this is the image. Okay, so this is the, whenever you are selecting this, you have to select that PWR file. Suppose I'm just selecting these two files and open. Okay, so next you have to go to the parameter, and here you can use the different filtering method. Okay, so see, suppose different filtering method is actually useful for different purposes. So for this purpose, I just use the mean filter. Okay, but some people are actually using the FOSS filter whenever they are doing some study over the urban. Okay, so that is, you have to did some research on that, which filter is actually giving. So azimuth window and window size range, so that I make as a 5.5. Okay, and we can save it in a same way. Okay, wherever this two file you want to save, you can save it the same way. After doing this, you have to execute. Okay, so once you execute it, how this file will come? So see, I'm not just running, because it will running, it will take so much time. It's a large data. Okay, so I'll just show you the update output directly. So once you do this, you will get this two information. See now. Okay, so I'm just showing you this VV, and this is also VV. So before filter and after filter. Just see this. So this is before filter and this is after filter. See now here how means good quality after filtering you will get. Okay, so this is a before filter image, this is after filter image. Okay, so that is the reason we go through with this filtering technique. So this we did over the VV and VH both. So now after doing this, what you have to do, filter is done. So now we have to means geometric correction, okay, or geocoding is required. So to doing geocoding, first thing, you download the DEM. So see, this is a DEM I already downloaded. See, this is the part of the DEM. Okay, so as this image is not registered, so it is not come. So why I'm not doing that time subsetting, I'm just telling you. So whatever area I want this much area. So that much area DEM I downloaded. So when I put the geocoding process, so whatever the area I'm selecting according to my DEM, so that much area is automatically extracted to me. So that is the advantages here. Okay, so now to doing this, I already downloaded this DEM. Okay, so to do this DEM, it is not directly able to go for the geocoding process. So you have to process this DEM first. So process is what? You have to convert this DEM TIFF to DEM will format. Okay, so to doing this, you have in Sarscape, you have this generic TIFF format. Okay, so you just double click over this. Okay, select that. Okay, so the DEM you have, this is a process DEM. So maybe you will not able to find it here. So you just select change all files. So you will get this build file. You select it, open. Okay, and then go to this import. So you select here as a global data. Okay, parameter, you select geocoded true, and data unit you have to select as a DEM. Okay, and after this output, wherever you want to save, you just save it and then execute. So once you executed it, you will get this DEM will file. Okay, so the file which is in TIFF, it is actually now converted in a DEM will file. Okay, so this DEM will file will now, what we have to do, we have to give as an input in my the geocoding, whatever we are going to do. In that case, it is required. So I am going to this geocoding now. Under this Sarscape, you have this geocoding option. So you just double click over this geocode. Okay, and you have to select your data. Which data you have to select? The filter data which you did. Okay, so just go to the filter image and select the both image and open it. Okay, so you have this filter image, and now you have to go to optionals. Okay, optionals you can make it left. Okay, otherwise you go to directly here, and here you have to select your DEM. So that DEM which you already converted in a will format, that DEM only you have to need to select it here. So just go to geocoded process DEM, change the DEM. So this bill you will get as an input. Okay, so now it will subset your area and it will rectify your area on the basis of this DEM. So now you go to this parameter tab, you give the Excel size, whatever it is mentioned it here. Okay, so only thing you have to convert this in a sigma naught value. So that is a dB. So you just select that. Okay, and go to the output and save it wherever you want to save. Okay, this two you just save wherever the folder, target folder you are just found, and then just execute it. Okay, so once you executed it, I just switch off this, make it zoom to layer. So this is your DEM data, and this is now your after power fill. So this is, you can understand by this also. So this is a PWR imported file. This is a field corrected file. This is a geo DB file. Okay, the geo corrected DB file. So this is the over the you will get a VV and VH, both you will get. Okay, so now the next steps, what you have to do, I have to create the radar gram or radar interprogram. I have to create to get a different color of the different, to understanding a different land use land. So to doing this, you have to create a ratio, band to band ratio. So you have an option here, band algebra. So you just go to this band ratio. So here you have this two value. Already we have in numerator and denominator. So in numerator and denominator, you have to select your VV first. So you have to select, see which one is your VV. So this is the two value. Okay, so this is VV and VH. Okay, so you just select your VH as a numerator and VV as a numerator. Okay, enter the pair. Okay, and go to OK. So here wherever you want to save, you just save and make it OK. So you will get a ratio file. So ratio file I already created. So that is this one. Okay, so if you, so this is the three file which is actually required. Okay, this is the three file which is actually required to create a radar interprogram. So radar interprogram I already created. Okay, so if you want to see, so this is actually radar interprogram. So it's actually a combination of the three bands. Okay, so see, this is a combination of the three bands. Like one is your VV, VH. Okay, so this is another one is this is the ratio of the VV and VH. Okay, this is a ratio file. Okay, so if you want to see this live, then I just show you. I just removing this. I just opening these three. You can go to this band combination. Okay, you go to the band selection. Okay, and you can take it like this. This VV, VV, VH, and ratio. Load it here. Okay. So using these three bands, so what I am showing here, different color is actually mentioning what? Different color is actually mentioning the different height of the object. Okay, so as this water value, which I am coming as very nicely, it is actually demarcated. Okay, so that is a low value actually. So how we'll understand? See, to doing this, what I now the next part we did in some other software, it's called ArcGIS. You can do it here also, but I feel comfortable to do it there. So I just take it in ArcGIS. So to doing that, I just export it as a TIFF. Okay, I just export it as a TIFF and I take it in the other software. So okay, so this is a. Can you able to see my screen?
Yes, sir.
Yeah, yeah. Okay, so this is a window of the before flood. Okay, and another date I also extracted. So that is a before flood and after flood. Okay, so after cycle. Okay, so this is a before cycle and after cycle. So if you see this from the image also, we can very easily understand how the water area is actually spread so much. Okay, so now what I did, we did a classification. Okay, so here you have a geoprocessing tool. So using geoprocessing tool, you can go for ISO data clustering technique. So here you have see, this is the okay. If you search something ISO data clusters, then also you can go for search, it will come. So ISO data cluster, what we did, we give this file as an input. Okay, so I just show you, it is coming. So I just give on to input the, I will show you what the one image. Okay, so this is, you have to select the date, particular date data which you actually want to do the unsupervised classification technique. And after that, I just given a classes number as a 4. Okay, I just make it a 4 classes classification, and then I just save it wherever I want to save. Okay, I just make it run. So I will get a output. Suppose I want to see that. Okay, so this is the image. Okay, so this is a before cyclone where I will get the water area. The same thing I did for the means our another date. Okay, after cyclone image also. But then what we required a layer of water. Okay, so see, this is the water layer of before cyclone, and this is, I think, after cyclone. Okay, so this is a two layer. Okay, so this is a two layer which actually we extracted. Okay, and this is, we did, how we did this means from the reclassify, means from the water we reclassified it in a two group. One will be the water, one will be the not water. See this image, we'll find only the two values. One will be the water, one will be the non-water. Okay, but you see one thing, whenever we'll do this thing, okay, so we have the three value 1, 2, 3, 4. So here 1 is actually my target water. But whenever you will do this thing over the NDWI technique in water indices technique we are going to do, then your high value will be your water. So that is the difference with the radar and optical whenever you are going for this classification. So that you will remember. Okay, so now here whatever I did, so that is a two different layer I actually extracted. And next thing which you have to do, that is you have to convert this layer. Okay, so raster to polygon. So this is the raster to polygon. Okay, so you have to give your input this raster data and you have to give as a polygon. So once you give this, so whatever the data sets, it will convert it in a shapefile, and from that shapefile, whatever there is a water layer, okay, using the attribute selections query, you can select only the water. Okay, so this is the, suppose the final, I just show you the final water area. So this is the final water area actually. Okay, so switch off this all things. Okay, switch off this. Okay, so this is the actually final water area. So this is water flooded final. Okay, so this is the final water area. Okay, so this is area before flood and this is after flood. Okay, and from this we will put a mask over the flooded area only if we extracted the flooded area. And if you see, we make a bookmark where is area. This is a kind of area you can make it a bookmark. If you click on the area, so it will show you which area is actually I want to actually demarcate where is most affected by the flood. So that is also, you can very nicely find it out here. So see this area name, I don't know. Okay, sometime because so I want to open one layer here that is called base map layer. So here it is called as an image hybrid. So if you want to click over this image hybrid, so with this layer, you will get all the local information about that layer. So that's why it is coming as a diamond harbor. So it is a South Bengal, it is a area. So down diamond harbor, and you will get information in very high resolution images. Okay, so using this is actually this base map, this layer is actually helping you whenever you are doing some study. So whatever it is, like surface temperature or anthropometric heat, so somewhere you will find, so there is a very high surface temperature is coming, and where is the place name you want to search. So you have to go in a field. So in that case, you just open this hybrid base layer and you can easily demarcate it. Okay, so like this way